Hello everyone, welcome back to my channel. So today we are starting with the topic applications of heating effect of electric current. Now what is heating effect of electric current? Whenever there is a flow of an electric current along the circuit, a heat is produced in the resistor. Okay, so now this production of heat is used where on? Okay, we see it in our daily life. See, the heating effect of electric current is into many electrical appliances, like I can say electric geyser. Okay, we have electric bulb that uses this effect. Electric bulb, oven, electric oven I can say, electric iron, electric furnace. There are many effects. This effect is used into many appliances. Okay, electric iron. So these are the most common ones. Toaster, everything, all such are used. These appliances are working on what? On heating effect of electric current. That's their fundamental procedure. Okay, now see, we are going to consider firstly now how is the heating effect of electric current used in an electric bulb. Okay, we are going to see that. Electric bulb. See, how is the bulb? Your bulb is made up of, inside there's a filament. Suppose I'm considering like this. Now what do I mean by the word filament? A thread-like structure through which current passes. Okay, filament is nothing but thread-like structure. Okay, now current is passing. How it's giving us energy or how it's giving us light? Okay, because of that current, it starts heating up. That is the heating effect of electric current. Okay, and because of that it glows, light comes. Okay, so that is due to what? Heating effect of electric current. Now mostly this filament is made up of substance like tungsten. Why? See, tungsten has got what? Tungsten. It has got high melting point. Means it needs a lot of current can pass through it. Then only it would melt. Right? High melting point and high resistance. High resistance. Fine. Now this is very important. High resistance. See, we have seen in our previous video, heat produced is directly proportional to the resistance. The higher the resistance, the more is the heat. Right? More heat is produced means it's going to emit more light. Okay? And further what it is, here the chemicals are chemically inactive gases they have put. Chemically inactive gases they put in the bulb. Why? So that it doesn't undergo oxidation. Oxidation is not there, so its life increases. Okay? Chemically inactive gases कौन सी है? Argon and stuff. Okay, fine. So in an electrical bulb, we mostly use tungsten material to make our filaments. Okay, why we are using tungsten? Any substance which has got very high melting point. So that why we are using that specific property of high melting point. See, if the melting point is low, it's going to melt fast, right? And with the bulb would get destroyed or it get damaged, right? So the higher the melting point, its capacity for the electric current to pass through it is more. It can bear that much of electric current to pass through it. Okay, that's why we use that high melting point. More high the resistance, more heat would be there. More heat is there, so it's going to emit more light. Okay, that's how the heating effect of electric current is used in an electric bulb. Now next we'll see how the heating effect of electric current is used in an electric iron. Electric iron also works on this principle, heating effect of electric current. Okay, its consumption is electricity and it gives heat to us. Okay, second is electric iron. Okay, see now electric iron is made up of a high coil of high resistance. Okay, this is my coil. It's of high resistance and it's kept between two mica sheets. Now I'm going to tell you why they are using mica sheets. Okay, this is my, and it's inside a metal block. This is my metal block. From here, suppose we use this part to iron, and a insulator is attached as a handle. Suppose I'm taking an insulator as my plastic handle is there most of the times. Why? So that we don't catch shock or we don't get heat. Okay. Now see, this high resistance is there. Suppose my electricity is coming here. Because of the high amount of current, okay, high amount of heat is produced, right? As the Joule's law of heating tells us, more the current, more the heat, more the resistance, more the heat. Okay. Now this heat is produced, right? Mica, this mica sheets, it's a group of minerals. Okay, they have found out specifically this one because of its property. It's used in an electric iron. Okay, this is a good conductor of heat. It's a good conductor of heat. Good conductor of heat. So it passes the heat over here on the lower surface of our iron, and that heat we use for ironing clothes. Okay? Now, mica being a bad conductor of electricity, it is a bad conductor of electricity. So even if we touch by mistakenly the lower part, okay, we won't get shock, electric shock we wouldn't feel. We'll just get electric heat. We can only feel the heat. We do not get the electric shock. Okay, that's the reason we use this substance. It's a mineral group called mica. It's used mostly for sheets, for iron, making electric iron. It is used most of the times. Okay, that's how the heating effect of electric current is used. The current is passing through this coil. Because of the current, it gets heated up. The temperature, that heat is transferred to the bottom of the iron through the mica sheets. These are my mica sheets. Mica. And that heat we use on the clothes to iron them. Okay, this was the effect of electric current, application of heating effect of electric current. Okay, now next we are going to see what are the wires provided by our electricity board. And fine, we are going to see how are they attached and all. Home appliances we are going to study now. Okay, see, wires provided by electricity board, straight electricity board I can say. They provide us the three wires. First is the live or the phase wire. Okay. Second is the neutral wire. And the third one is the earth wire. Fine. Now, after this, suppose now I am taking my electric appliance. Across my electric appliance, which wires would be attached? Across the electric appliances, we'll have these two wires attached. Phase wire and the neutral wire is attached across the electric appliances. Now the third one we are going to discuss is what is the potential difference provided by the board across in India electric appliances. See, the potential difference across each appliance is same. Okay, and it is 220 volts. How much is it? 220 volts. Okay, now we always place See, it's better to place our electric appliances in parallel in a circuit. Why do we prefer parallel arrangement? Suppose I have these are my one appliance, this is my second appliance, and this is my third appliance. Okay, so if this is not working, okay, it doesn't matter, these both would still be working. Or if I remove this one, it doesn't matter, these two would still be working. So that's the reason they arrange most of the times electric appliances in parallel. Okay, now how you should arrange the fuse. Now what is the fuse and how it uses the effect of electric current in fuse? See, fuse is always attached in series. Now why? In series with the electric appliances. Now why? Why do we attach electric appliance in fuse in electric appliance in series? Okay, see what does the fuse does? It does not allow, it stops the large amount of current. It stops large amount of current to flow from the appliance. Okay, so it basically stops or it protects the appliance from getting damaged. Okay, large amount of current to pass through the appliance. How it does that? It stops. Okay, we have to remember that. It stops large amount of current or current more than the specified value to pass from the appliance. How it's going to do that? See, this is my fuse and this is my appliance. Okay, this is my fuse. It is mostly made up of an alloy of low melting point. Suppose I am going to take tin or anything, lead, I can take anything of low melting point. Now its melting point is low, means what? I am going to set, suppose its capacity of this appliance for the flow of current is, suppose I am considering 130 ampere. Okay? So if a more current than 130 would flow, because of its low melting point, it starts melting. This fuse starts melting, so it gets disconnected from the appliance, so the current wouldn't flow from that appliance and it gets saved, right, from being damaged. That's how the fuse protects the appliance from getting damaged, by stopping the flow of current. Okay, that's why we always attach the fuse in series with the appliance. Fine. Now next we are seeing is short circuit. Short circuit means what? Catching fire. Now how it catches fire? See, when our live wire, okay, this is my live wire and my neutral wire, bare, live wire and bare neutral wire, it comes in contact with each other, direct contact with each other. What happens? Their resistance becomes very low. Resistance decreases or it becomes very low. Okay, and a large amount of current flows through it. A very large amount of current flows through it. Because of the current, the temperature increases, right, of the components. Temperature of components increases. Heat is produced, right? So it catches, heat is produced and it catches fire. Understood? when the bare live wire and the bare neutral wire comes in close contact with each other. Okay, so the resistance decreases and a large amount of current starts flowing through. Whenever there is a large amount of current, the temperature of the component starts increases. Because of the reason the temperature, large amount of heat is produced, and because of the production of heat, it catches fire. Okay, so this is short circuit, which usually happens. Fine. Now see, the next we are going to see is overloading. What is called overloading? Anything which is more than the permissible or its capacity is overloading, right? So overloading is nothing but as the word suggests us, when a large amount of current moves more than its permissible value flows through the circuit, it is called as overloading. Now when this happens, when overloading happens, okay, see, I have got high power rated appliances, right, like geyser, geyser motor, all such things. When I switch them on simultaneously, geyser, oven, motor, so that time overloading happens. So to avoid overloading, what can I do? How to overcome overloading? To avoid overloading, okay, to avoid overloading, we should not attach many electrical appliances in the same circuit. Not attach many electrical appliances in the same circuit. Okay. In the same circuit. Fine. That's how we can do this to avoid overloading. Fine. So these were the applications of the heating effect of electric current. If you like my video, do give a thumbs up, subscribe to my channel, and do not forget to share it with your friends.